Hey guys, week 3 video notes here today. We're going to start adding and subtracting rational functions, rational expressions rather. So this is going to be kind of a piece of cake if you remember some simple rules, right? If you remember how to add, subtract fractions, which we're going to review to start this, right up here. We're going to review how to do that. If you kind of remember that and you remember how to eliminate, kind of simplify rationals, then today's going to be a cakewalk, right? It's going to be pretty simple. So without even talking about it, right, let's get started. So quick review again, we're going to start here. So 3 over 7 plus 1 over 7, right? Now some of your first instincts might be, hopefully not too many of you, but some of you, you might not remember too much, and you might say, well, you just add across. So we have 4, 3 plus 1 is 4, 7 plus 7 is 14, right? That's a big misconception, and when people are working fast, you might start doing that, right? But that is not correct. Right? That's not correct. That's not what you want here, right? It's not what you want. What's going to happen is that denominator's got to stay the same. It's got to stay the same, right? So 3 plus 1 is 4, so the top does change, but the bottom here is going to be, sorry about that, but the bottom here is going to stay the same. So 3/7 plus 1/7 is just going to give us 4/7, right? Simple as that, right? Don't overcomplicate it. Don't overthink it. It really is that simple. That denominator is going to stay the same. And then over here as well, same concept, right? It doesn't matter what that denominator is, guys. In this case, it's x, meaning x represents anything, right? So anything, as long as the denominators are the same, right, and these both check out, check, these are both the same, then you're not going to do anything with it, right? You just add or subtract the numerators, the top, and you keep the bottom the same. So let's get rid of that stuff really quick to make it a little bit cleaner, and let's just work this one out. 8 minus 3, right? Just the top is what we're going to alter a little bit. 8 minus 3 is 5. And then that x is just going to stay on the bottom. So 8 over x minus 3 over x is going to be 5 over x. All right? Pretty simple stuff. Pretty simple stuff. So now let's get into the meat of this stuff. Right? Let's get into the meat of it. Number 1. Right? Again, as simple as you can. First thing, always, it doesn't hurt to just check it off. Make sure the denominators are the same. So 16x, 16x is the same thing as 16x. Yes, check, right? So now that we have that situated, we just worry about the top, right? We just worry about the top. So 6 plus 4 is going to be 10, and the 16x will stay the same. And now this is the different part, right? Now we're not just adding fractions, so it's not just be there and be done, right? We've got to simplify, which with fractions you're going to simplify as well if you get something that you can simplify. But now we've got to simplify. So 10 over 16x can be simplified. These are both divisible by 2. So I'm going to divide the top by 2, divide the bottom by 2, and I'm going to get 5 over 8x. And that's my final answer. Right, so really we're just got to add numerators. Right, add numerators, and then simplify as needed. Right, simplify as needed. So we add the numerators, simplify as needed, and we're done. Right, so that's really the gist of today. It's really not going to alter too much. So let's continue on. Hopefully that one made sense to you, right? So as we continue on, now we start to see that maybe these numerators aren't going to add up to be, a perfect number every single time. 6 plus 4 is an easy one. This one's not going to be always as easy. Right, it's not always going to be as easy. So 3x squared over x minus 8 plus 6x over x minus 8. Now again, your first check is just to make sure these denominators are the same, which they are. They clearly are, right? So now that that's over and done with, we just got to add up the numerators, right? So 3x squared plus 6x. You can't do anything with those. Those are different terms. So you just got to keep them separate. So 3x squared plus 6x over that x minus 8 does not alter, right? That denominator is never going to change when you're doing this, right? So there we have it. But that second step, you've got to simplify as needed. So let's simplify the top there. I think I can take out a common factor from this, right? From this up here. I can take out a common factor. Well, it looks like I could take out a 3x from this term and a 3x from this term. That looks like the greatest common factor to me. So let's take that out. So I've got a 3x coming out. What do I have left? I have an x, and I have a plus 2. Right? 3x squared divided by 3x is x. 6x divided by 3x is 2. And that bottom's not going to change, right? I've got x minus 8 So now you're looking for anything to simplify, right? You're looking for anything to, reduce, to cancel out on the top and the bottom. In this case, we don't have that, right? We don't have that. So this is actually just going to stay like this. Pretty simple, right? Now let's get on with it, right? So again, guys, I know I kind of went through that fast, but just to go over it really quick again, you're just going to add these numerators because the denominators are the same. We did that. And then you simplify really quick just by taking out a greatest common factor, seeing if you can cancel anything out. In this case, we couldn't, so we're done. Right? Moving on, let's go down to number 3. Again, doesn't hurt for a quick check. Denominators are the same. Check, check, right? No big deal. So we just go straight for the numerators. Now we're subtracting, right? Don't ever overlook this. Oops, sorry. Don't ever overlook this and think for sure that you're going to be adding or subtracting, right? Don't go too fast. Always make sure you look at that to see what you're doing, right? So we're going to be subtracting here. So again, these are different terms. 6x squared and 3x are different terms. So we are going to keep them separate, right? So we've got 6x squared minus 3x over 2x minus 1. Right, 2x minus 1. Remember that denominator does not change, and we're just combining those numerators, right? And again, our next step is to simplify, right? So we're going to take out a greatest common factor. Again, in this case, we're going to take out a 3x, right? So the 3x comes out of the top, and we're left with a 2x minus 1. Now we see something we can cancel out. Right, now we see that this 2x minus 1, let me change the color here really quick. This 2x minus 1 is the same as this 2x minus 1, meaning we can cancel them both out from the numerator and the denominator. Right, we can cancel those out. So what do we really have when we cancel those out? Well, all that's left is this 3x right there. So this guy simplified is just going to equal 3x. But hopefully you remember from last week's unit, or last week's lesson, that when we cancel something out like this, it does not just disappear. This 3x down here has got to abide by the laws of this subtraction expression and this expression up here. It's got to abide by those laws. And this tells us that there's a restriction in the domain, right? When there's something in that denominator, it means there's something restricted in the domain. So what are we canceling out here? Well, we are canceling out 2x minus 1. Now, when is that going to be equal to 0? I don't know. Let's find out. Right? So let's set it equal to 0, and let's see what x has to be for this to equal 0. Well, I'm going to add 1 to both sides. So I get 2x equals 1. I got to divide by 2. And I get that x equals 1/2. So when x equals 1/2, this function will not exist. Right? When x equals 1/2 and I put that in here, that's going to give me something over 0. And that's not okay. So that must be a restriction on my domain here. So, yes, my function is going to be 3x. My new expression is going to be 3x, but I've got to restrict that function to say as long as x does not equal 1/2. Oops, sorry. Pen gave out a little bit. 1/2. So again, to recap just a little bit, this expression is going to simplify down to this expression, right? But then that is simplify a little bit more by canceling out this 2x minus 1 from the top and the bottom. But just because we cancel it out does not mean it does not affect my graph anymore. It does not affect my expression, right? This expression has got to abide by this. So while this does simplify down to this, it's got a contingency that x cannot equal 1/2, right? So there you have it, right? We're kind of working in adding and subtracting, and we're still having that stuff from last week where you're having to find out what restrictions of the domain are, right? So yeah, coming down here to number 4 and 5, this is a little bit different. So this is going to introduce us to the next thing we're going to be doing with adding and subtracting, right? And I'm going to kind of recap this video here at the end, but this will get us kind of ready. So finding the least common multiple, right? Least common multiple. So we have 2 different types of problems here for least common multiple, and really this is all you kind of need to know. So this first one, number 4, right? You have 2 different factors, right? You have 10x and you have 10x times x plus 4, right? Which one of those is the bigger one? so to speak, right? Which one is going to be the bigger expression? Well, we've got 10x, and we've got 10x times x plus 4. The bigger expression is obviously going to be this one, right? That's the bigger one. This is a 10, sorry, okay? So basically what you want to ask yourself is, what can I multiply this smaller expression by to get to the bigger expression, right? So I've just got a plain old 10x. Well, what can I multiply 10x by to get to 10x times x plus 4? Can I do that? Well, the answer is yes, you can do that, right? What is this one missing? Let me get this pointer out. What is this expression missing that this expression has? Well, the answer is easy. It's x plus 4, right? The answer to that, how do I get this to look like this? Well, I just multiply this one times x plus 4. So if I were to do that, that would be my least common multiple, right? As long as I multiply this expression here by x plus 4, it will become the same thing, right? And just to show you that, let's do it. So 10x times x plus 4, I would simplify that down to just 10x times x plus 4, right? And now these two look the exact same. So their least common multiple is 10x times x plus 4, right? And that's okay. So yeah, you just got to be able to multiply something to this expression to get it to look like this, right? Exactly that, right? Now coming down here, now coming down here to number 5, right? This one can be just a little bit more tricky because the answer isn't quite as obvious, right? It's not quite as obvious. So looking at this one, x squared plus 5x minus 14 and x plus 7, right? So I've got x squared, I'm going to rewrite these, 5x minus 14, then I've got x plus 7 over here. Right, and actually I'm going to do that in a different color here. Sorry about that. X plus 7. Right, so what can I multiply? Obviously this one is the bigger one this time, right? This is the bigger expression. So what can I multiply x by? Or I'm sorry, what can I multiply x plus 7 by to get me x squared plus 5x minus 14? The answer is not so obvious, right? It's really not. So when you start to look at this, you can start to play with this a little bit. Well, this isn't quite its simplest form, this x squared plus 5x minus 14. Isn't in its simplest form, so let's factor that. Let's factor it. So what two numbers are going to multiply to get me negative 14 and add to get me positive 5? Well, let's see. Looks like positive 7 and negative 2, right? So I can factor this out. Let me get back to this green color. I can factor this out to being x plus 7, x minus 2. So those two are the same. Now I'm not dealing with that anymore because I've just simplified it to x plus 7, x minus 2. Now the answer is a lot more obvious. Well, how can I get this guy to look like this? Right? Well, I've got the x plus 7 already. All I need is to multiply it by x minus 2. So just to make sure, let's do that. So let's say, okay, x plus 7, and I'm going to multiply it by x minus 2. Well, if I rewrote that without the multiplication sign and just brought them together, it would look exactly like, sorry, this is messing up right here. Oh, geez. X, and then get that. So these two are going to look exactly the same, right? This and this look exactly the same. So its least common multiple is going to be x plus 7, x minus 2. Right? That's the least common multiple. Right? Same thing up here. The least common multiple was 10x times x plus 4. Simple as that, right? Simple as that. So, just to kind of go over this again, guys, all you got to do here is add. I should have put add slash. Let me erase that really quick. Should put here add slash subtract. Right? Ooh, those last two were pretty ugly. Subtract numerators, right? So I'm going to add or subtract the numerators and then simplify as needed, right? These first two didn't really need to be simplified, right? You just add them up, and there you go. And these other two did need to be, or this other one, I'm sorry, this other one did need to be simplified, right? I subtracted, I brought out a common factor. Here you go, I subtracted, brought out a common factor, and then realized, hey, I can actually cancel these out. But when I do cancel out from the denominator, remember, that leads to a restriction of my domain, right? So that's the big thing I would say. Don't forget when you do eliminate from that denominator, it does restrict the domain. That's something that some people will forget, and you will get wrong answers because of it, right? And then finally down here, guys, you just want to find the least common multiple. A lot of times it's just going to be what can I multiply one expression by to get to the other expression. Or you can do it in another method, which we're going to go over on Thursday, by just multiplying each expression by the other. But until then, guys, hope this video helped. Hope you guys do well on the homework. Again, we're available for tutoring all day, every day, basically, every weekday, I mean. So if you do need help, we're all available for you. Otherwise, thanks for stopping by, guys, and hope you have a great rest of your day.